So this is what we start with. The distance AB equals the distance CD. We'll expand that into the distance formula. Cosines are x's, sines are y's, right? So the cosine of alpha gives us the x coordinate for A. The cosine of beta gives us the x coordinate for B. That's x1 minus x2 squared, right? And then sine of alpha gives us the y value for A. Sine of beta gives us the y value for B. That's y1 minus y2. So that left side is the distance formula with cosines and sine. So let's start by writing that up. Square root of r cosine alpha minus r cosine beta squared plus r sine alpha minus r sine beta squared. That's our left side distance formula. That's the distance between A and B. Now we say that equals the distance between C and D. So that is x1 minus x2 squared plus y1 minus y2 squared. So that gives us r times the cosine, and that angle is alpha minus beta minus r times the cosine. D is at 0. Cosine is 0. Squared. Plus r sine alpha minus beta minus r sine 0 squared. Let's real quick look at a couple values on this right side. What's the cosine of 0? What? R. The cosine of 0 is
1.
It's 1. Yep. What's the sine of 0? 0. So that's why they don't have a term on the right here, because the 0 zeroes it out. And that's why it's just r right here, because r times 1 is just r. So we'll combine that step with let's square both sides to get rid of the radicals. And it leaves us, and I'll draw arrows to new lines, because we're going to need a couple lines for a couple steps. So that leaves us with r cosine alpha minus r cosine beta squared plus r sine alpha minus r sine beta squared equals r cosine alpha minus beta minus r squared plus r sine alpha minus beta, this is 0, so that quantity squared. Now the next step, these are binomials. We'll FOIL them out. Parker.
I don't understand why you wouldn't just like use the radical to get rid of the square in the first place.
Because let's talk about just numbers first. Let's say this is a number and that's a number. Does this equal, that's my question, does this equal 5 plus 3? And that's a question for everybody.
No.
No. Because this is, 5 squared is 25, 3 squared is 9. That equals the square root of, what, 34? Which is not 8. Square root of 64 is 8. So it doesn't work like that. If these were multiplied together, you could. Since they're added together, it doesn't reduce in that way. So we have to square both sides to get rid of it. And then we still have the same thing underneath. Does that make sense? Yep. It's just how they reduce, because they're separate terms instead of factors. Factors would reduce, terms you need a little bit more. So now I'm not gonna go. We're gonna like visually and verbally process this FOIL. I'm not gonna write out the entire thing per se. So this is this binomial times itself. So first would be r cosine alpha times r cosine alpha. That's r squared cosine squared alpha. The inner and outer terms would be r cosine alpha times minus r cosine beta. Having two of those, it'll give us minus 2r squared cosine alpha cosine beta. And then our last, minus r cosine beta times minus r cosine beta will give us positive r squared cosine squared beta. Does that make sense? That's the foiling, just in one step. Now we have to do the same to this one. R sine alpha times r sine alpha is plus r squared sine squared alpha. Our middle terms are r sine alpha times negative r sine beta, and negative r sine beta times r sine alpha gives us minus 2r squared sine alpha sine beta. And then our last is negative r sine beta times negative r sine beta, positive r squared sine squared beta. So that's the entire left side, that full line there. We'll do the right side, I'll indent it a little. This is also a binomial. So we multiply our first ones, r cosine alpha minus beta times r cosine alpha minus beta, r squared cosine squared alpha minus beta. Our middle terms, r cosine alpha minus beta times negative r times r cosine alpha minus beta gives you negative 2r squared cosine alpha minus beta. And negative r times negative r plus r squared. Now this last one's not a binomial. We're just distributing the exponent. That gives us plus r squared sine squared alpha minus beta. So the next step, if you look at all these terms, there's an r squared in all of them. So verbally, that means you can factor an r squared out of each term in the top, factor an r squared out of each, or in the left, factor an r squared out of each term in the right. You then divide both sides by r squared. They all go away. We'll do that by just making them go away. But that's the math behind it. You factor them out and then divide both sides by r squared. Be careful here. This is just r squared itself. So that leaves you with 1 still. We have a plus 1 there.
Why?
Because r squared divided by r squared is 1. So if you were to divide by r squared like here, it'd be 1 times the sine squared alpha minus beta. So it can be rewritten as sine squared alpha minus beta. But if you take an r and it's just r squared out of just an r squared, you're still left with that 1. And because it's not multiplied by anything else, we have to actually write that 1. It still stays there. Okay. So now let's rearrange. We have a cosine squared alpha here, and we have a sine squared alpha. Let's write those together. So this is a new step. Sine squared alpha plus cosine squared alpha. Excellent. We'll get there in just a second. We have a cosine squared beta and a sine squared beta. Let's write those together. Sine squared beta plus cosine squared beta. And that leaves us with a minus 2 cosine alpha cosine beta and a minus 2 sine alpha sine beta. Minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. So that is the left side rearranged. Now let's rearrange the right. We have a cosine squared alpha minus beta and a sine squared alpha minus beta. Let's write those together. Sine squared alpha minus beta plus cosine squared alpha minus beta. We have a 1 plus 1, and then our last thing is minus 2 cosine alpha minus beta. This is the fun part. What does this equal? 1. It's our Pythagorean identity. There's an alpha instead of a theta, but the variable you use for theta doesn't matter. Sine squared plus cosine squared, 1. What does this one equal? 1. Down here. What does this equal? 1. So we're going to combine a couple steps just to simplify it. But this leaves us with 1 plus 1, right? Is it okay if I write that as 2? Then in this term, we have a negative 2 as a common factor. So I'm going to factor out that negative 2. So it's 2 minus 2. And then when you factor out that common factor, we have cosine alpha, cosine beta. Since we factored out the negative 2, it's now plus sine alpha, sine beta. Plus sine alpha, sine beta. Does that make sense how I went from that to here? Now we'll do the same on the left. This equals, or on the right, this equals 1. And we already have this 1. 1 plus 1 is 2, right? 2 minus 2 cosine alpha minus beta. 2 and a 2. Subtract 2 from both sides. Those go away. Negative 2 and a negative 2. Divide both sides by negative 2. Those go away. That leaves us with the cosine of alpha times the cosine of beta plus the sine of alpha sine of beta equals cosine of alpha minus beta. Boom. In college, they always tell you to write Q-E-D. Q. I don't know, I think that's kind of a cool phrase. But I don't know what it means. But it just means you're done. So take a look at your cheat sheet. There's a specific way you need to read these, because there are sum and difference identities, but they're written together. See in the bottom right, sum and difference formulas. What we did was prove the cosine of alpha minus beta. That's the middle portion, right? See how the plus and minus is